Introductory Physics Lab number 3, Calculating the Mass of a Black Hole. We are given a starter program and information about a star orbiting under gravitational influence of a black hole, and we're asked to use physics to calculate the mass of the black hole. Our system consists of a star with its mass given, and we are also provided a spreadsheet in an CSV format with the XY positions. Our surroundings are the black hole of unknown mass, and our time step is 1 day converted into seconds. Assumptions for this lab are that F-net on the star is due only to gravitational force by the black hole, that the black hole's position is located at the origin and is stationary, and that our distance, r, is from the center of the black hole to the center of the star. This is a sketch of the problem. We have our star orbiting around a black hole, and we have our black hole situated at the origin of our XY axis. Important relationships that we'll need for this laboratory are the momentum principle, and specifically the change in momentum over the change in time is roughly equivalent to F-net, and the universal law of gravitation. The methods that we're going to use is we're going to take what we are given and use that to calculate F-net, given that we can calculate the change in momentum over change in time with what we have. And we're going to ask our computer program also to calculate the distance and the mass of the black hole for us. The first while loop in Python is used to define the velocity components, and the second while loop is used to actually define velocity and momentum and the change in velocity and change in momentum. And we continue on there and we tell it to find our F-net for us and break F-net down into parallel and perpendicular components. I did attempt to insert instructions into the code for calculating the distance between the star and the black hole and the mass of the black hole, but I was not successful with this, and I ended up calculating this by hand. Before we look at the results, we'll look at the orbit. And we can see that the computer did indeed break it down into a vector for F-net parallel and F-net perpendicular. And the results I got show the same. I hand calculated the distance between the star and the black hole with a calculator, and then I used the information I had. I rearranged the universal law of gravitation algebraically and found that the mass of the black hole is 2.012 e plus 31. And this is a sketch of the solution. So what does it mean? How are F-net parallel, and F-net perpendicular different from the change in momentum over time and its parallel and perpendicular components? Essentially, the former causes the latter, and specifically, F-net causes the change that we have in momentum. This relationship is best described by calculus, where numerous iterations are done over and over to best get the answer. And what if the black hole was replaced by a different black hole and the observations on the star remained unchanged? Could you tell the difference? Not by these methods. These methods only calculated physical components, specifically the mass. Is it possible for the new black hole to have a different mass from the one just calculated? No, not with our current understanding of gravity and orbits. However, Maybe there's something about black holes that we don't know yet. In summary, we used the mass, orbit, XY components, and time to find FNet, calculated at our distance, and used them both to find the mass of a black hole. And thank you very much.